this was actually a big step for me, because spending this, normally I kept everything invested in the business. And so this was treating myself finally. So one of the best things I ever did. The enjoyment I got out of this car, these cars are such little tiny go-karts where you really do feel like you're attached to the road, and you can feel the texture of the road through the steering wheel, because there's no power steering.
Right.
And they stick to the road so well, but then that electric drivetrain is like putting rocket thrust on a go-kart. It's just, so you're sitting you get this raw, visceral driving experience, but with leather interior, air conditioning, and power windows.
Right. And emission-free to boot.
Yes, right, yeah. So when it came out in 2008, the Tesla Roadster got the energy equivalent of 125 miles per gallon, roughly. It's silent, and it never breaks. This is the car that has changed the automotive industry. And there's only 4 cars that changed the entire automotive industry. The Benz Patent Motorwagen started the automotive industry. The Ford Model T, the 1908 Ford Model T, put any car company that did not adopt production line technology out of business. And before World War I, there were 1,300 American automotive companies.
Wow.
You know, we're used to 3.
Yeah.
1,300 choices that you had out there for a car. But anybody that was still assembling their car ended up going out of business because of the Model T. So there's the 2 most important. The third, people would never guess, but for the viewers, in the year 1900, half of the cars in the United States, a little bit more than half, were electric. And about 30% were steam, and only about 20% were internal combustion. And the reason was, if you owned an internal combustion vehicle, 1 out of every 3 people ended up with a broken arm. You'd crank that thing to get it going, it would kick back. And in, I think it was 1910, the best friend of the chief engineer of Cadillac stopped to help a lady that was stalled on the side of the road, cranked her car, it kicked back, broke his jaw, and he died a month later from an infection. And so between, I can't remember what the guy's name was at Bendix that developed the electric starter. Do you remember?
I don't remember.
Okay.
No,
Well, the 1912 Cadillac, first car to have an electric starter, and that killed off steam and electric cars, and caused internal combustion to become predominant. By 1928, the last electric car company went out of business. There was a delivery van that was made until 1932, but from 1928 to 2008, 80 years, people tried and failed to make an electric car. And then this was the first car to reach that right balance of price, range, charge time, battery life, and performance. And they are so good looking.
Yeah.
So beyond that amazing performance that they have, and beyond, and being so important, people, by the end of this decade, people will be looking back at this car and saying that was the car that killed the internal combustion engine. By the end of the decade, probably, you know, I used to say, back when I'd give people rides in this back in 2011, 2012, and I'd say, you just know that in 20 years, 80% of the cars being made will be electric. And I was wrong. By the year 2030, about 90% are going to be electric, and internal combustion will be almost dead by that point.
It all started with that T0 that's up on the wall there. That was the car that in 1997 was lighting up the auto world, in that they had gotten a federal grant, small company in San Dimas, California, AC Propulsion Systems. They landed a federal grant to build 3 electric sports cars to prove that electric sports cars could be fun. They finished 3 cars, put lead acid batteries in them, and you can see there are 28 12-volt batteries in there. It had a range of about 80 miles, and when they took this car to Laguna Seca, it was doing 4-second 0 to 60 runs, embarrassing Lamborghinis, Ferraris, and McLarens of the day.
Right.
A lot of people took notice, and Martin Eberhard was one of the first ones that went to see them and said, are you guys going to build this car? They said, no, we're an engineering company. He had just sold an ebooks business. He said, do you mind if I continue to build this car? They said, no, we'll even give you a test mule so that you can build, continue to make a T0 or something like it. His idea was to take a electric sports car glider or empty shell and convert it to electric using this drivetrain out of the T0. And he also had them convert one of these, and it was VIN number 1, to lithium-ion batteries, or as he called them at the time, laptop batteries. So then Martin started to look for a car company that would sell them empty gliders or empty sports car frames. Lotus stepped up to the plate and said, yeah, we'll sell you some Lotus Elises. And they got a contract in place for 2,400 of them. They began to ship them to the US and put in the ACP drivetrain and found that it was not reliable enough for what they were trying to do. So they eventually developed their own power electronics module and own battery system. The difficulty that they also ran into is that trying to shoehorn that 1,000-pound lithium-ion battery pack into a Lotus Elise was not successful.
Right.
So they ended up changing the frame on the Elise. Then they had to change all the body panels on the Elise, and that's why today only 7% of the Tesla Roadster is Lotus Elise. Well, Mike, let me show you the auto shop of the future. We have a lot of visitors that come here, and the first thing that they're astonished is that this is an electronics lab. And the reason is, these are Roadster parts, for example, just like the ones that are in your cars. This is the power electronics module, the three-phase inverter. And what we're doing here is the equivalent of an engine rebuild in an electric vehicle by changing all the wear components. These 21 electrolytic capacitors get replaced. There are engineering problems with the insulating material. There are contactors in here that have aged through use. And the other part of it is repairing all of the electronics in the Tesla Roadster. This is the HVAC controller. This is a switch pack. There's a different HVAC controller for the 2.0s. And the reason we end up having to do this type of reverse engineering and creating schematics is because a lot of this doesn't exist. And the only way to keep these cars alive is to have a component level repair effort done to these types of boards. Unfortunately, the parts for your car, like the electronics, will most likely never be made again because there's too small an owner pool. And those of us in aftermarket just don't see the return on investment.
People don't realize that the Tesla Roadster is the car that started the modern electric car industry. There would be no battery electric vehicle available today had it not been for this little sports car that reached that right balance of price, range, performance, charge time, and battery life.
And the tenacity of Elon Musk to hang in there through threats of bankruptcy to keep the company alive long enough to make a sustainable vehicle, which then ended up being the Model S.
Not just bankruptcy, but there's so many people that for some reason hate him for what he's done. And all he's done is improve everybody's life on the planet. He's probably affected more people in a positive manner than any person living or possibly any person in history. I mean, Nikola Tesla with AC affected a lot of people's lives. But Elon Musk, I mean, people hate him for some reason for trying to create a backup plan for humanity and taking it on his own responsibility to colonize Mars. And gambling half of his net worth on that while simultaneously gambling the other half of his net worth and then going in debt at one point to drag the entire automotive industry into the 21st century, kicking and screaming. The first car of the 21st century was the Tesla Roadster. And every time I get in it, still, it feels like I'm driving a piece of the future.
Very much so. You can see what's going on out in the shop here with the cars.
I love this. So I don't think there's any place on earth where you can see as many Roadsters in one spot, right?
This is it. No, we have over 50 of them here at any given point in time, and they come in like while you've been here. 2 are going out today, and another 2 are on their way in.
So there were 2,500 made for the world, but about 1,500 for North America, the USA and Canada. And How many are still roadworthy, do you think? Is it like 1,000 or 1,200 or?
We have a census program on our website. We've invited for 2 years now Roadster owners to register their Roadster. And we are up to about 2,000 Roadsters accounted for globally.
Wow.
There were 2,400 exactly, 2,412 were built originally. And of that, about 2,000 are left in play. Now, granted, there are a few dupes in there, but the margin for error is fairly low.
Yeah, I know my first one met an untimely end, is the way I like to say it, but it's definitely no longer roadworthy.
Yeah.
There was probably, should have been sold as a parts car. I don't know if it ever was.
Yeah. We have to build all of our own test equipment. You can't go on Amazon to buy power supplies and load banks, and so we end up having to build much of the equipment that we use to repair Roadsters.
So this goes to each different sheet in the battery pack, huh?
Exactly. This will actually, we can dial in the voltage and the current that we want to charge the sheets at, and what it does is it balances every single sheet so the voltages are identical. So by the time it goes back up inside the car, we're going to get maximum range because that pack is basically balanced before it even goes in. And here you can see the 1,000-pound battery pack dropped out of these Roadsters. Yeah. And those are the sheets there to the right that we take out.
Oh, okay.
And the type of work we do to repair them. And typically what happens with a sheet like this is you have a resistive cell that begins to drain one of the bricks, and there's 69 cells in a brick. And what we are able to do is actually isolate that one resistive cell. And everybody asks, well, how do you replace it? Is it like a flashlight? You open it up and put some new batteries in?
Right, you don't.
All we do here is there are little fusible link wires, and we snip out that cell. It takes it out of circuit, and the car never realizes that 1 out of 7,000 cells went MIA.
Yeah. Huh. So, and these are 2 of the original battery packs. So these are how old?
These are most likely anywhere from 12 to 15 years old, and they would have come out of one of these 1,000-pound packs.
And they're still working. And I mean, they've already exceeded their expected life significantly, right?
They
thought that they would last about 10 years, maybe?
10 years is what J.B. Strobel told us about a year ago or so. And he said he was pleasantly surprised that his Roadsters are now going on 14 years at that time. No one really knows how long the original Tesla Roadster battery packs are going to last because we're not seeing the end-of-life issues. Now we are seeing those in the 2016 packs. There was a replacement that was built in 2016, and for some reason those cells are dying before the original legacy packs are. Yeah,
that was a higher energy cell that the battery pack, when it was new, had a lot more range, right?
Yep. Yeah, the original was 2.2 amp hour, the replacement was 3.2 amp hour, and the brand originally was Panasonic Sanyo, and this was an LG brand that began to fail.
Yeah, okay. Do we have any? We've got one here with the trunk open, so we can show the power electronics module.
Sure.
And oh, check out those seats with the orange inserts there. So now the motor is right underneath the PEM, right?
It's underneath here, and when we get over to a car up on a lift, we can show the motor and how small that is. This is the 3-phase inverter here. This is the power electronics module that we saw in the lab back there, which is full of circuit boards. This is fed by the 1,000-pound battery, which starts here and goes all the way to the back of the seats and then drops about 3 feet or so. And eventually the DC comes into here, it goes out here down to a 3-phase AC induction motor, which then drives or powers the car.
You know, one of the things I've always wondered why they will list these as having a single-speed transmission. A transmission is a band-aid to make an insufficient technology function. That's the reason there's like 8-speed transmissions, and it actually does have gears for reverse. With this, you're just switching the polarity of one of the reverse is not a gear. Right. Reverse is just putting the AC electricity in one of those wires is reversed, and the motor just wants. So, if this car was not electronically limited in reverse, it could do 120 miles an hour in reverse.
Right. Yeah.
Yeah.
That's a good point. Be kind of scary though. Yeah.
Yeah, right. So, but, and I absolutely love the sound that these make, and that is really not the motor, that's the reduction gears, right?
Yeah.
And so the transmission consists of a reduction gear, which is not a transmission, and then some sort of locking device for park, right? And that's about, that's about it.
That's it.
And so it isn't a transmission. This car does not have a transmission. It's got a reduction gear. And that's,
or a transaxle, you know, like your Pantera, for example.
well, it's I don't know if I'd call it a transaxle. I don't know what to call it, but I think that Tesla made a mistake by saying that this car doesn't need a transmission instead of saying it's a one-speed transmission.
What legend has is that they actually did have a two-speed transmission in these originally, and it was a Borg-Warner transaxle or
but the torque kept on shredding the trans.
Exactly, and they finally ended up saying, well, is top speed really that important? It's going to be limited to 130 miles per hour because we're out of RPMs with a single speed, gearbox.
Yeah.
So if you want to see the motor, we've got some visible here.
Okay.
And I'm going to show you the 2.0 motor because it's more visible. It has less stuff around it.
Oh, okay. Yeah.
That guy right there that has the 3 orange leads coming out of it.
Right.
So it's about the size of a crock pot. The outside diameter you see there is actually, the motor's actually smaller because that's a heat sink that goes around it.
Yeah, I can see all the fins.
Yeah. That little guy puts out 288 horsepower.
Wow.
Which, of course, with an internal combustion engine car means you'd have to have an 800-pound engine block to achieve that kind of power. And from there, it gets fed into that gearbox there, 2 half shafts, couple 4 CV joints, and it couples directly to the rear wheels.
Yeah, and then this is all a box aluminum frame that's riveted and bonded together.
Yeah. Yep.
And,
this was a Lotus specialty, was that pink epoxy. And you know, we've seen these cars in collisions. They use pop rivets to hold together the aluminum and sometimes bolts. Those will rip, and the aluminum rips before this epoxy does.
Wow.
That's how strong this is. It must be a molecular bond.
You know, it's that giant frame rail that saved my life, and that some kid lost control of his car going into a hairpin turn and bounced off of an SUV and came out from behind the trees about 50 feet in front of me, sideways in my lane, still doing about 55 miles an hour. I was doing about 25, and he hit me head on. It was the most violent 1/10 of a second in my life.
Wow.
He pushed me in a 1/10 of a second. I was going 25 miles an hour forward, and then suddenly I was about 40 feet back. Yeah. Wow. It was really something. But I stepped out of the car and just started snapping pictures of the accident and it's because of that giant frame rail that guided his vehicle around me.
Thanks for watching part 2 of our new series on the original Tesla Roadsters. We had a lot of fun making this video, so let us know in the comments section if you'd like to learn more about the vehicle that, in the future, will become known as the car that killed the internal combustion engine. And as always, thanks for hitting the like button and subscribing. We'll see you soon.